Okay, the objective of the lesson today is how we can use an equation to graph a line. And so we're going to use the information from an equation that's slope and y-intercept. Okay, so we're going to look at an equation, we're going to put it in slope, y-intercept form. We're going to use that information to plot points and then draw a line through those points. Okay, so if I were asked to draw a graph of the relation 2x plus 3y equals 9, the first thing I want to do is I want to put it in slope-intercept form. Slope-intercept form is the equation that's solved for y in terms of x. So it looks like y equals, and we use m to be the slope, so that's the coefficient of the x, and the constant is at the end, so we write that as plus b. So right now I want to take this and I want to solve this for y in terms of x. So first thing I want to do is I want to get rid of this x term on that side. Now it's attached to the y term with addition, so I want to subtract it. Okay, so I have 3y is equal to 9 minus 2x. You can see this is, well, then I'm going to actually get rid of the coefficient to the y by dividing each side by 3. So I have y is equal to, now remember this is a binomial divided by a monomial, so I have to do this. And I'm going to write that 2 divided by 3 as a coefficient to the x. Okay, so y is equal to 3 minus 2/3 x. Now, in order to get it in slope-intercept form, we need the x term to be first and the constant to be second. So I'm going to use some keep, change in order to get it to addition and then switch it around. Okay, so this is y is equal to 3 plus, now I can either put the sign of the fraction on top of on the numerator or on the denominator, but I can't do both, so I'm going to choose to put it on the numerator here. Okay, now to get this in slope-intercept form, I have to switch those two around, which I can because I have addition, which is commutative. Okay, now the slope of the line is -2/3. Okay, so right here, the slope, I can pick out the slope here. Let me just rewrite this here, -2/3 x plus 3. Okay, there's that equation. Now the slope is -2/3, and the y-intercept is 3. Okay, so the y-intercept I can plot right away. That's the intercept of on the y-axis, so I can put this as 3. The slope of -2/3 can be thought of in two different ways. It can go down 2 and right 3, or it can also be, because you can think of it as 2 over -3, so it can be up 2 and left 3. Okay, so if I go down 2 and right 1, 2, 3, okay, or from the first point I can go up 2 and to the left 3. Okay, and all of those things are going to get a point on this line. Now, from this last rightmost point, I can go down 2 and right 3 in order to get another point to figure out where that line sort of crosses the x-axis. It looks like it crosses it at a place that's not an integer value for x, but that's okay. It doesn't have to cross as an integer value there. Okay, so this is the line, and always label your line with the equation. So you can label it, it's better to label it in slope-intercept form. Okay, that's the line -2/3 x plus 3. Okay, so let's go over the steps. We put it in slope-intercept form. We found the y-intercept. We used the slope to find 2 more points on the graph, and we drew a line through those points. And I guess step 5 would be labeling the line. Okay, so you might want to pause the video to do this on your own. Okay, if you were to solve this, if you were subtracting the 2y term, the first thing I like to do is I actually like to add that on the other side. That makes it positive, which is a little easier to deal with. Okay, and then I can subtract 9 from both sides, so I have 2y is equal to 3x minus 9. Divide all the terms by 2, so I have y is equal to 3 over 2x minus. Now, I want to keep the slope as a fraction, but I want to write the 9 over 2 as a decimal. Okay, Okay, so 3/2 x minus 4.5 is equal to y. And I can use the reflexive property of equality to write it as y is equal to 3/2x minus 4.5. The reflexive property of equality says that I can switch everything around the equation sign. So I can put this on the right, or on the left, and I can put this on the right. Okay, so we have this equation. Okay, and the reason why I want to keep the slope as a fraction is because the numerator tells us that we have to go up 3, and the denominator tells us that we have to go down, or to the right 2. Okay, if I had 3/2 is equal to 1.5 as a decimal, that tells us a little less information, because then I'd have to put it over 1. This would say up 1.5 and right 1, but if I had just left it as a fraction, it would give me the same information. That's why we leave slope as a fraction. Now we want to keep the y-intercept as a decimal because it's actually something that we are graphing on a number line on the y-axis. And you know what, this equation isn't quite in y-intercept form because y-intercept form looks like this, where there's a plus sign in between the x term and the constant. So let me just use a little keep change here in order to change that. Y is equal to 3/2 x plus negative 4.5. Okay, so we want to plot negative 4.5, and so that's just on our graph down here. Okay, so we plot the y-intercept, and then we use the slope in order to find 2 other points. So this is going up 3, so 1, 2, 3, and right 2, 1, 2. Okay, so here's a new point right here. Do it one more time, 1, 2, 3, and up 1, 2. Okay, when you go up 1 whole unit, remember that's you want to keep it, because it's at negative 4.5, it's at a half mark. You kind of want to keep it halfway between the 2 integer marks. So here's our line, and we want to label it with the equation in slope-intercept form. Okay, and you don't have to keep that as plus a negative 4.5. You can keep that as minus 4.5 if you'd like. Okay, you might want to stop the video to figure out how to do this. I'm going to pause the video and work out all the problems while you work out the problems too. Okay, so I started working on the equation, and the first thing I did was I added 10y to both sides. Then I subtracted 15 from both sides. Then I'm dividing both terms on the left-hand side by 10, which was the coefficient to y. 5x divided by 10 is 1/2 x, or 1x over 2, but I like writing it as 1/2 x, minus, this could reduce to 3/2. That's equal to y, so I'm going to write that as, and I'm going to use keep change real quick here because I want my y-intercept to be, because in slope-intercept form there's a plus sign between the 2 terms there. So I'm going to switch everything around the equal sign. Y equals 1/2 x plus negative 3/2. Okay, so negative 3/2 is the y-intercept, so I'm going to go and find that on my y-axis here. Negative 3/2 is negative 1.5, so that's right here. My slope is 1 1/2, so I go up 1 into the right 2. Up 1 into the right 2, up, I could keep going here, up 1 into the right 2. So here's all these points on this line. So there we go, and I can label it with the slope-intercept in slope-intercept form. Okay, how do we graph a line from a table of values and find the equation? So let's say that I'm given this table of values, and I want to graph the line and find the equation. So let's first graph the points on the table. So I'm going to pause the video and do that. Okay, so I've plotted all the points on the table on the graph, and if I draw a line through them, then I have my graph, but what is my equation? Right, so remember the equation you can write in the form of slope-intercept, right? So basically, I keep these x's and y's there. They remain as variables. But what I'm trying to solve for is slope and y-intercept. So from the equation, you can see that the y-intercept right here is 3. You can also see it in the table because the y-intercept is the y-coordinate when the x-coordinate is 0. So here my b is equal to 3. Now my question is, what is my slope? Well, you know how to find that both from a table of values. You can choose 2 points here. Or you can find it from a graph. If you pick 2 points on the graph, these 2 points right here will suffice. You can go, so between these 2 points you go down 2 and right 1. So down 2 and right 1 gets your slope. That reduces to negative 2. So we have y is equal to negative 2x plus 3, and that's my equation. Now I said before to keep the slope as a fraction, and I guess what I meant to say is keep it as a fraction unless it reduces to an integer. Okay, so this negative 2 over 1 reduces to an integer, so I'm going to keep it as an integer. All right, so there is my equation, and there is my graph. Okay, now finding equations from slopes and a point. So let's say that I was given what is the equation of the line that passes through a point here, 4, negative 6, and has a slope of 1/2. Okay, so first thing I want to go back to my slope-intercept form. Okay, and remember I'm solving for slope and y-intercept. Now, you might be able to do this right off the bat because you understand, the slope I already have, right? That's 1/2. So right now with the slope, I can put that information in 1/2 x plus b. Now b I still don't know. B is a number, and it's not a variable. I just have to find out what that number is. Now, the trick with this is, you know one of the solutions. You know that a solution for this equation is 4, negative 6. Meaning when x is 4, y is negative 6. So if you actually put that specific solution into this general equation, you'd be able to figure out what b is. So let's put negative 6 in here is equal to 1/2 times 4 plus b. Okay, now I'm going to put this little arrow over here. That means that negative 6 is equal to 1/2 times 4 is 2 plus b. If I solve this for b, I'd subtract 2 from both sides. Remember, negative 6 minus 2 is equal to b, but that's the same as negative 6 plus negative 2. So b must be negative 8. Okay, so rewrite the equation in slope-intercept form. Well, I know that b is negative 8. I know the slope is 1/2, so I have y is equal to 1/2 x minus 8. Okay, or plus a negative 8, which is actually slope-intercept form, plus a negative 8. Okay, there we go. So we took a point and we found we put the slope into the equation, and then we used a specific solution in order to find out what b was, and then I rewrote the general equation without the use of that specific solution. Okay, let's try it one more time. So let's say we have a line that's passing through negative 10, 10. It has a slope of 1/5. So the slope of 1/5 means that I can put that in for m. Okay, a solution of negative 10, 10 means that I can go ahead and put 10 in for y. Remember, this is x, y. And let's see what happens when I put negative 10 in for x. Okay, it's not equal to, I don't mean to write equal there. Okay, so 10 is equal to negative 5 plus b. Okay, so let's add 5 to both sides here. B is equal to 15. Okay, so now I have the two pieces of information that I need for my equation. I have the slope and the y-intercept. So y is equal to 1/5 x plus 15. Okay, so the things that you learned today is you learned how to look at, let's go back here. You learned how to take an equation and go directly to the graph. Okay, you also learned how to take a table and draw the line and find the equation. You learned how to use a point and a slope in order to write the general equation. Okay, so that's the end of the lesson for today.